Okay, so now I am going to solve the 1 marks question of this GATE 2025 exam. So let's start. Okay, and again, I am not reading the questions very well in every time. You already have the solution, response it, and answer key. So I will only solve the problem. Okay, yeah. Yeah. So the first question is for a two-dimensional hexagonal lattice with lattice constant A, the atomic density. So this is some two-dimensional hexagonal lattice. Okay. Yeah. So this is the lattice, and let's say this is the center. So all these things, all these sides has length A. Okay, and if you know from the two-dimensional hexagonal lattice that this all are equilateral triangle. Okay, so this all angles are 60 degrees. Okay, so they are all equilateral triangles. So there are six total equilateral triangles. So the total area of this configuration, if A is the lattice constant, then this is 6 into root 3 by 4 A square, right? So this is the total area. And now what is the, I mean, total, I mean, contribution of atoms? I mean, how many atoms are there? The effective number of atoms. Okay, so how is, what is the effective number of atoms in the configuration? So there is one atom. I mean, not the, sorry, the diagram is wrong. Let me draw it clearly. So there is one atom, there is another atom like here, 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 another one like here, and at the center there is one another. Okay. Now this angle is 120 degree, right? This angle is 120 degree. So how many are like this? One, two, three, four, five, six. So six atoms are like this, which are contribution of 120 degree. So six atoms into pi r square into 120 by 360, right? So these are all these atoms which are like this, and there is an extra atom at the center. Okay, these are 120 by 360 is equal to 3, so is equal to 2 pi r square. Okay, and there is an extra atom at the center if you consider this. Okay, so 1 into pi r square. So if you consider this center atom, this will be 3 pi r square. And if you don't consider that there is any central atoms, like these are all like touching each other. I mean, they are like this, they are closely packed, like there is no vacant space. I mean, at the center there is no space for another one. Then for test configuration it is only 2 pi r square. Okay, so this is the area. Now contribution is effective number is, if you have to calculate the fractional area, then you have to do by this way, that 2 3 pi r square divided by total A. Okay, or 2 pi r square by total A. Now they are telling about the atomic density. So what is the number of effective atoms present there? Okay, so effective number of atoms. So what is this configuration? This is giving you 2. Okay, so 6 into 120 by 360, that is equal to 2, right? So 2 into 6 into root 3 by 4 into a square, right? So the number is 4 by 3 root 3 a square. Okay, so this will be the right option. And if you consider this one, this extra one, okay, so then it will be 4 into 3 into 4 by 6 into root 3 a square, right? So this will be the option, but I think there is no options matching with this one, so this will be the correct. Okay, so if you don't consider this central atom, then this will be the right answer. So for this question, these are the some primitive lattice vectors given, and you have to calculate that if what kind of atom, what kind of lattice it is, and what is the area. So the first thing is you can calculate directly the area. Okay, so area has formula A dot B cross C simply. So A into 100, for this one it is 100, for A j cap this is 010, and for this A3 it is half half half, right? So now simply calculate this determinant of this thing, that is A dot B cross C. So it is 1 into half minus 0, that is sorry, there is a cube for each lattice. There is a, so a cube, so it is a cube by 2. So only one option is matching, that is this one. Okay. Now the second one is that is truncated harmonic oscillator potential. That is this kind of potential, and we know the energy eigenvalues for this kind of potential is like same n plus half h cross omega, but only difference is n is only odd numbers, not the even ones. Okay, so the first one is obviously 3 by 2 h cross omega, the ground one, and the second one is n is equal to 3. You have to put n is equal to 3 here, so it is 7 by 2 h cross omega, the odd numbers only. Okay, so the ratio will be 3 by 7. Okay, now this one, what is the d sigma by d omega? So d sigma by d omega, it is equal to minus mu. Mu is the, I mean, reduced mass. Okay, so mu by 2 pi h cut square into VR into r square sine theta d theta d phi dr into e to the power I q r cos theta. This is the most general formula. Now, if you simplify it a little bit, if you integrate d phi first, then your 2 pi will be gone. And if you integrate this e to the power I q r cos theta into sine theta d theta, finally you will get r sine q r 2 here extra, a q here, and dr. Now your vr is g into del q bar, right? Del q bar. That means you have to put r is equal to 0 in this equation. So put r is equal to 0, this will give you 0. Sine q r, if you put r is equal to 0, this will give you 0. So the overall result is 0 simply. So it will not dependent of any of theta and phi. Okay, it will just simply 0. Okay, a Joule Thomson expansion is an isenthalpic process. You have to know it. The For this question, okay. Now for this question, see, for matter waves, E is equal to h cut square k square by 2m, right? This is the energy. So Vg is equal to 1 by h cut dE by dk, right? This is equal to h cut k by m. And what is your Vp? Vp is equal to E by h cut k. Vp is equal to E by h cut k. That is equal to h cut k by 2m. Okay, so Vg and Vp are not same. So this thing is obviously correct. For matter waves, Vp and Vg are not same. This is obviously correct. Now, for this option, for electromagnetic waves in a medium, Vg and Vp can be more than C. No, it is not. Vp can be greater than C. Vp can be greater than C, but Vg, the rate of energy transport, is always should be less than C. Okay, so this is not true. For electromagnetic waves in a medium, Vp represent the speed with energy propagates. No, Vp represent the phase propagation, how the rate of phase propagation. Okay, and Vp is rate of phase propagation, how phase is quickly, how the phase is changing. This phase is changing, and Vg is the rate of energy propagation. Okay, so this will be wrong. And for matter waves, Vg into Vp less than greater than C square. No, they both are less than C for matter waves. Okay, so they both are less than C. They can't be greater than C square. So this is also not correct. Okay, so now for the Drude model, you have to calculate what is R. So R is rho L by A. Now rho is 1 by sigma, and sigma is n e mu. These things you know from electronics also, right? So n e, and mu is e tau by m. So n is called tau by m. So this option will be correct. Okay. Which one has a strangeness quantum number -1? Just you have to remember these things. Okay, these things are something which is very difficult to remember, but for exam purpose, it's you have to remember this if you want to get marks. But these things are very hard to remember. Okay, so this thing has -1 strangeness number. This is zero strangeness neutron. This chi plus is chi plus, chi zero, chi minus, chi plus is -2 strangeness numbers, and this is also zero strangeness numbers. There is something called lambda, which is also -1. There is something called hyperon, which is -3 strangeness number. These are some famous examples where strangeness number is not zero. So it's better to remember these things. Okay, yeah. Now these things you have to get output t is equal to 1. What should be your input? Okay, so don't check with the options. I will tell you a better way. Just do a backward calculation. Okay, so to get t is equal to 1, now this is a AND gate. Okay, so your both these values should be is equal to 1, right? Otherwise your AND gate output will not be equal to 1. Now further backward, do a backward interpolation, like this is going backward, okay. So to get 1, this both output should be 1. To get both of this one, you have to both this both input should be 0, because this is not gate. Now to get 0, q should be is equal to 0, and for get p plus q is equal to 0, this should be also is equal to 0, because otherwise 1 plus 0 is 1, right? So the option A is only correct. For so this kind of option, don't go the process with checking with every option. So if your option 4 is the correct option, then I mean some time is lost in this checking process. Okay, so don't lose your time. Just do the backward interpolation like process. Okay, backward calculation, and you can get the options quickly. Okay. Okay, so next question is, so nuclear energy level of mirror nuclei using the empirical fact, nuclear force can be said to independent of the following. You already know that nuclear force is independent of charge. Okay, spin parity they have dependent on. Okay. For this question, residue, this is already you know that it is a second order pole, so the technique is minus d dz of, for z is equal to 0, the technique is minus d dz of z minus 2 whole square at z is equal to 0, and for z is equal to 2, the thing is minus d dz of 1 by z square at z is equal to 2, right? Uh, Sorry, this is z minus 2 cube, right? And sorry, this is 1 by 2 factorial d2 dz to 1 by z square. Okay. So this is not minus, this is minus 1 to the power 2, so it is plus. Okay, so if you solve this, you will get like minus 3 by 16 and 3 by 16. This is straightforward calculation, I am not doing it, you can solve it, right? Okay. So the next one is simply the relation with number density with Fermi energy, how it is related. So number density is proportional to n to the power, I mean, Fermi energy proportional to n to the power 2 by 3. So n proportional to e to the power 3 by 2. So n by 2 proportional to, let's say, e to the power 3 by 2. You have to calculate what is E and relation between E and EF. So if you take the ratio of these two, then e to the power 3 by 2 into 2 is equal to ef to the power 3 by 2, right? So e is equal to 2 to the power minus 2 by 3 into ef. So it will be minus 2 by 3. Okay. Next one. Paramagnetic material containing paramagnetic ions with total angular momentum J is equal to half escape at absolute temperature T. Ratio of magnetic field required for the 80% ions to be in lower energy state to that required for having 60% ions to be in the lower energy state. Okay. So if you have a spin half electron or atom in some magnetic field, you have two energy state. What is plus mu b and minus mu b. Okay, plus mu b and minus mu b. Now, to, you have some probability associated with some particles in minus UV state, and you have some other probability with part how many particles are in plus UV state. So, what is the probability? Probability is simply e to the power. This for this probability e to the power minus mu v by kt by z, and for this one the probability is, sorry, e to the power minus mu b by kt divided by z, and z is what, z is that it this plus this. Okay, without this thing, so z is this plus this. Okay, so the first thing is, they are saying that the lowest state had 80% the ions. In the lowest state there is 80% ion. Okay, so let's say mu b by kt is equal to x, right? So e to the power x into e to the power x plus e to the power minus x is equal to 80%, that is 4 by 5. Okay. So 5 e to the power x is equal to 4 e to the power x plus e to the power minus x. So e to the power uh, x is equal to 4 e to the power minus x. So e to the power 2x is equal to 4, and 2x is equal to log 4. This is for the 80% case. Now for the 60% case, there is some, let's say the variable is now y, the magnetic field is changed. So e to the power y into e to the power y plus e to the power minus y is equal to 60%, that is 3 by 5. That means, so your 2 e to the power y is equal to 3 e to the power minus y. So your e to the power 2y is equal to 3 by 2. So your 2y is equal to log 3 by 2, right? Now your temperature is not changed. K is a constant, mu is a constant for this person. Only the magnetic field is changed. So simply the ratio of x by y will give you the ratio of magnetic fields, right? So it is log 4 divided by log 3 by 2. So this will be your option. So now check log 4. This is log 4 actually. 2 log 2 is simply log 4, right? So log 4 by log 3 by 2. This will be the correct option. Okay. Which one of the following is correct for hydrogen atom, ground state of hydrogen atom? So yeah, the quadratic Stark effect is zero for a non-zero for ground state, but the linear Stark effect is zero because see your for the Stark effect your H prime is some constant into R cos theta kind of thing. Okay, and if our ground state is 1 by pi a cube to the power minus R by a. So if you now take the average of H prime, you have to do some kind of integration which is cos theta sin theta d theta 0 to pi, right? So this will give you 0. Okay, so linear Stark effect is 0, it is true. It has definite parity, true. Spin orbit coupling, the spin orbit coupling, for n is equal to 0 is the ground state. So for n is equal to 0, the only possible value of n is equal to 0. And spin is half. So the j values possible is only half. There is no other possible j values. So it is not split at all. In spin orbit case, this n is equal to 0 state will only get j is equal to half, but there is no other j state. So it will not split. Contrast to for n is equal to n is equal to not 0, n is equal to 1. Contrast to n is equal to 2 state, if you consider l is equal to 1, n for n is equal to 2, l is equal to 1 is a possibility, and s is half. So your two j values are possible. J is equal to 3 by 2 and j is equal to half. So there is splitting. There is some splitting, obviously. But for n is equal to 1, there is only possible value of L is 0. So there is no splitting at all. So spin orbit coupling is 0 for ground state. Yeah, it is also true. Hyperfine splitting is 0. No, hyperfine splitting is not 0. Because I already show you that J is half is the only possibility for n is equal to 1. That is ground state. And for hydrogen atom I, the nuclear spin is also half. So the two possible f values is 0, half minus of 0 and half plus of 1. So there are splitting of, there are definitely hyperspine splitting. So this option is not correct. Yeah. Okay. So which of the following options are correct for photons? Okay. So it has rest mass 0, obviously true. It carries non-zero linear momentum. True, it is true. It is hc by lambda. Yeah. So this is the momentum. Sorry, this is the energy. Sorry, this is the energy hc by lambda. Okay. Photon has momentum lambda is equal to sorry h nu by c. This is the photon momentum, the energy divided by velocity. It carries zero spin angular momentum. Yeah, photons are bosons, right? We derive the things of photon radiation, that is u is equal to some a t to the power 4, p is equal to u by 3v, this radiation pressure for photons. We already considered that photons are bosons. Photons are like bosonic particles with spin 0. So I think it is true, okay, but probably in options it is not giving true, but I think it should be true. Okay, and it has two linearly independent state of polarization. Yes, this is true. That is the case why when we write, recall when we write g omega d omega, or say GEDE, what is the technique? Technique is V by H cube into 4 pi p squared dp, right? And substitute p is equal to h nu by c for photon. But the thing is, you have to consider the two linearly independent state of polarization. That is, a degeneracy of two should be multiplied. That's why your GED is something like 8 pi nu square by c cube d. Otherwise, there should be 4 pi nu square by c cube. The factor of 8 comes because multiplication of 2, because of this assumption that two linearly independent states of polarization. So according to me, A, B, C, D all should be correct, but I think the option answer key is not giving C as a correct option. Maybe I am wrong in something, but you can surely comment. Okay. Which of the following nuclear beta decay has to be a three body. Okay, so which of the evidence are showing that it is a three body problem, three body beta decay? Okay, so yeah, the continuous distribution of electron energy is obviously a proof, because otherwise, if it is a two body problem, then from conservation of linear momentum and conservation of energy, you can exactly found what is the energy of this proton and the electron. Okay, it is not the case. That's why we assume that it is a three body problem, and later it is proved that yes, there is something called neutrino and anti-neutrino. Okay, so spin of final state, yeah, it is true, because the initial spin is half. Final spin, if it is a two body problem, then proton is half, electron is half, then it should be a spin one or spin zero state. But this is not the case. There is something, definitely another spin of particle is sitting here, and that is the neutron and anti-neutrino. Okay, so these two are the mass of electron is nothing to do here, and mass of proton is also nothing to do here. Another thing which may be given in the option, that is lepton number. The lepton number should be conserved. If you consider the lepton number, the right hand lepton number is 0. For this is 0. For electron, the lepton number is 1. So if it is a two body problem, lepton number is not conserving. So there is something definitely with lepton number -1 should be sitting here, and this is the case. Anti-neutrino has lepton number -1. Okay, so lepton number is also a right option if it is there. Okay, yeah. So now this question, 1 mole of ideal monoatomic gas at absolute temperature T undergoes free expansion to double its original volume. Changing entropy is S1. And identical amount at same gas absolute temperature 2T undergoes isothermal expansion to double its original volume. So that entropy change is delta S2. So ratio of delta S1 by delta S2. So you know, for isothermal process, delta S2 is simply, I mean, if you calculate that delta Q is simply delta U by plus delta W. U is 0 for isothermal process, and delta T is NR into 2T into log 2, right? If you divided by 2T, because you have to divided it by temperature, delta Q by 2T. So your delta S2 is NR log 2, right? NR log 2. Now for the free expansion case, delta W is 0, delta Q is 0, delta U is 0. But the thing is, we can connect this process as a reversible process. Okay, if you remember the theory of this expansion, the free expansion. So for in this case, we also assumed that the delta S is equal to dq by T. We can connect it as a isothermal process. Okay, so as it is reversible, so it is again in our log 2. Okay, so delta S1 by delta S2 simply 1. Both the cases in our log 2. Okay, so yeah. Now this one is, yeah. So a linear dielectric sphere of radius r has uniform frozen in polarization along z-axis. The center of spherically sphere initially coincides with the origin. So initially it has this kind of configuration, and the dipole moment is p1, and now it is moved to towards 0, 0 with center. What is the dipole moment is p2. So what is the value of p1, p2? Okay. So now respect to origin, this whole configuration has this intrinsic dipole moment plus some 2r into, let's say, now this is a sphere of course, and the dipole moment is pointing along this direction. That means it is minus charges here and plus charges here. Okay, so if you assume that two big balls of charges like plus q and minus q with infinitesimal small separation. Okay, so the dipole moment is 2r plus q minus q. So this, the shifting of origin in z direction will not affect the thing at all. Okay, so the P2 is simply that's is equal to P1, because this thing, the shifting of origin is not affecting the thing. Okay, just like 2R into Q minus Q, the two big balls of plus Q and minus Q, and they are sitting at 2R. Okay, Z is equal to 2R. So this is not going to do any effect. Okay, this is one actually. Okay, so the next one, the effective magnetic moment and Bohr magneton for the ground state of 4f ion with 6 unpaired electrons. The 4f shell is, you have to fill the 4f shell, the ground state, with the Hund's rule in integer. Okay, so basically the Hund's rule says that, I mean, many of teachers do many of techniques to form the ground state. I mean, I learned something from my teacher, so this is my technique actually. So 4f means L is equal to 3. So L, the ml values are from minus 3 to 3. So these are the possibilities. Okay, these are the possibilities. Now fill 6 electrons. One, 2, 3, 4, 5, 6. Okay. So what is the S value? S value is 6 into half, that is 3, and L value is 3 plus 2 plus 1 plus 0 plus minus 1 plus minus 2, that is 3. Now this total configuration can contain at most 7 into 2 14 electrons. So and it is only 6 electrons are filled, so it is less than half filled. For less than half filled case, J is simply L minus S, that is 0. So if J is itself 0, then the magnetic moment is also 0, but because it is directly proportional to Z, because it is mu J. Okay, so it is 0. Now for this thing, your this for a particular plane with 1 1 1, like this is the HKL configuration. Your theta is 30 degree at diffraction peak. You are getting theta is 30 degree. So now if you change the lattice constant to this value, then what will be your diffraction angle? And the angle is sine inverse 1 by n, and you have to calculate what is n. So 2d sine theta is m lambda in the first case, and the next case is 2 into 1.25 uh, multiplied by this d, because d is only scaled by this value. Sine theta is equal to m lambda. The first case, so 1.25 sine theta is 1 into sine 30, right? So sine theta is equal to 1 by 2 into 1.25, that is 1 by 2.5. So n is equal to 2.5, right? Yeah. The next one is consider a monoatomic chain of length 30 semi, and the phonon density of state is this much. So assuming Debye model, the velocity of sound in meter per second. So this is a one-dimensional chain, and you have to consider the Debye model theory. Okay. So for Debye model, what it says that g omega d omega is n simply, right? And what is your g omega? G omega is L by pi into Vs. This is your g omega. Now this g omega is given as 1.2 into 10 to the power minus 4. Your L is given as 30 semi. Okay. And pi is already there, and you have to calculate what is Vs. So simply use the formula, right? So Vs is equal to 30 semi, that is 30 into 10 to the power minus 2, divided by pi divided by 1.2 into 10 to the power 4. So if you calculate this, you will probably get 2500 divided by pi. Now calculate this whatever the value. So it will be 2500 by pi. This will be something around 700 to 800 in range. I mean, I am not calculating the exact answer, but this will be the answer, 2500 by pi. Okay. Now the last one, the delta plus baryon with spin 3 by 2 at rest decays into a proton and a pion. This is the configuration. Delta plus at positive intrinsic parity and pi 0 has negative intrinsic parity. So the orbital angular momentum of the proton pion system. Okay. So delta plus has spin 3 by 2. Now P has spin half, okay, and pi 0 has spin 0, okay. So the spin of this configuration is half, okay. So to match with 3 by 2, your L should be is equal to 1 or 2, right? So if you, the L cannot be 0, because 0 plus half is half, not 3 by 2. So for L is equal to 1, for L is equal to 1, your J can be half and 3 by 2. So it is satisfying. 3 by 2 is satisfying. For L is equal to 2, your angular J can be 2 minus 3 by half, that is 3 by 2, and 2 plus half, that is 5 by 2. So 3 by 2 is also present here. So L is equal to 2 is also a possibility, but L is equal to 3 will be not, because 3 minus half will be greater than 3 by 2. Okay. So the L is equal to 1 to these two are possible from this information, the conservation of angular momentum. Now there is another information given here, that is parity. It is delta plus has positive intrinsic parity and pi 0 had negative intrinsic parity. So parity is changed. Okay, the first one is plus 1, and the second one is minus 1 to the power L, this kind of thing, and there is minus 1. Okay. So L can't be a, I mean, L can't be a even number. So L cannot be a 2, because if L is equal to 2, that will be minus 1 to the power 2 into 1, that is minus 1. So parity is not satisfying this relation, that it is plus 1 and it should be minus 1. Okay. So to make it minus 1, L should be a odd number, and the only odd number possible here is L is equal to 1. So the right answer for this option is L is equal to 1. Okay. So yeah, that is I think all the one. I mean, two or three questions I am not able to solve actually. So I leave this at this time. But these are the rest of the things I have already done. So yeah.